In Part 10 of Lecture 2, we will discuss a first look at UNIX. UNIX was developed initially at Bell Labs and became operational on a PDP-7 in 1970. Work on UNIX at Bell Labs and later elsewhere produced a series of versions of UNIX. The first notable milestone was porting the UNIX system from the PDP-7 to the PDP-11. This was the first hint that UNIX would be an operating system for all computers. The next important milestone was rewriting of UNIX in the C programming language. This was an unheard of strategy at the time. It was generally felt that something as complex as an operating system, which must deal with time-critical events, had to be written exclusively in assembly language. Reasons for this attitude included the following. Memory, both RAM and secondary storage, was small and expensive by today's standards, so effective use was important. This included various techniques for overlaying memory with different code and data segments, and self-modifying code. Even though compilers had been available since the 1950s, the computer industry was generally skeptical of the quality of automatically generated code. With resource capacity small, efficient code, both in terms of time and space, was essential. Processor and bus speeds were relatively slow, so saving clock cycles could make a substantial difference in execution time. The C implementation demonstrated the advantages of using a high-level language for most, if not all, of the system code. Today, virtually all UNIX implementations are written in C. These early versions of UNIX were popular within Bell Labs. In 1974, the UNIX system was described in a technical journal for the first time. This spurred great interest in the system. Licenses for UNIX were provided to commercial institutions as well as universities. The first widely available version outside Bell Laboratories was version 6 in 1976. The follow-on version 7, released in 1978, is the ancestor of most modern UNIX systems. The most important of the non-AT&T systems to be developed was done at the University of California at Berkeley, called UNIX BSD, Berkeley Software Distribution, running first on PDP and then VAX computers. AT&T continued to develop and refine the system. By 1982, Bell Labs had combined several AT&T variants of UNIX into a single system, marketed commercially as UNIX System 3. A number of features were later added to the operating system to produce UNIX System 5. The classic UNIX architecture can be pictured as in three levels: hardware, kernel, and user. The operating system is often called the system kernel, or simply the kernel, to emphasize its isolation from the user and applications. It interacts directly with the hardware. It is the UNIX kernel that we will be concerned with in our use of UNIX as an example. UNIX also comes equipped with a number of user services and interfaces that are considered part of the system. These can be grouped into the shell, which supports system calls from applications, other interface software, and the components of the C compiler, assembler, loader. The level above this consists of user applications and the user interface to the C compiler. A look at the kernel is provided in the figure. User programs can invoke operating system services either directly or through library programs. The system call interface is the boundary with the user and allows higher-level software to gain access to specific kernel functions. At the other end, the operating system contains primitive routines that interact directly with the hardware. Between these two interfaces, the system is divided into two main parts, one concerned with process control and the other concerned with file management and input-output. The process control subsystem is responsible for memory management, the scheduling and dispatching of processes, and synchronization and inter-process communication of processes. The file system exchanges data between memory and external devices, either as a stream of characters or in blocks. To achieve this, a variety of device drivers are used. For block-oriented transfers, a disk cache approach is used. A system buffer in main memory is interposed between user address space and the external device. The description in this video deals with what might be termed traditional Unix systems. The term is used to refer to System 5 Release 3, VSR3, 4.3 BSD, and earlier versions. The following general statements may be made about a traditional Unix system. It is designed to run on a single processor and lacks the ability to protect its data structures from concurrent access by multiple processors. Its kernel is not very versatile, supporting a single type of file system, process scheduling policy, and executable file format. The traditional Unix kernel is not designed to be extensible and has few facilities for code reuse. The result is that as features are added to various Unix versions, much new code had to be added, yielding a bloated and unmodular kernel. As Unix evolved, the number of different implementations proliferated, each providing some useful features. There was a need to produce a new implementation that unified many of the important innovations, added other modern operating system design features, and produced a more modular architecture. Typical of the modern Unix kernel is the architecture depicted in the slide. There is a small core of facilities written in a modular fashion that provide functions and services needed by a number of operating system processes. Each of the outer circles represents functions and an interface that may be implemented in a variety of ways. This slide shows the family tree for Unix. All the way on the left, you'll see Research Unix, which was the version created at Bell Laboratories. You'll notice on the top is the so-called BSD family, and on the bottom, the System 5 family. From Research Unix came Unix BSD, Sun operating system, Next Step, which ran on the Next computers that Steve Jobs created after he left Apple, Xenix operating system, which was for PCs, and GNU, the project of Richard Stallman. On the other hand, in terms of System 5, you have commercial Unix from AT&T, Unixware, Solaris from Sun and Oracle, HPUX from Hewlett-Packard, and AIX from IBM. Please note that BSD, together with Research Unix, in effect begat Linux. SVR4, developed jointly by AT&T and Sun Microsystems, combines features from SVR3, 4.3 BSD, Microsoft Xenix System 5, and Sun OS. It was almost a total rewrite of the System 5 kernel and produced a clean, if complex, implementation. New features in the release include real-time processing support, process scheduling classes, dynamically allocated data structures, virtual memory management, virtual file system, and a preemptive kernel. SVR4 draws on the efforts of both commercial and academic designers and was developed to provide a uniform platform for commercial Unix deployment. It has succeeded in this objective and is perhaps the most important Unix variant. It incorporates most of the important features ever developed on any Unix system, and does so in an integrated, commercially viable fashion. SVR4 runs on processors ranging from 32-bit microprocessors up to supercomputers. The Berkeley Software Distribution, BSD, series of Unix releases have played a key role in the development of operating system design theory. 4.x BSD is widely used in academic installations and has served as the basis of a number of commercial Unix products. It is probably safe to say that BSD is responsible for much of the popularity of Unix, and that most enhancements to Unix first appeared in BSD versions. 4.4 BSD was the final version to be released by Berkeley, with the design and implementation organization subsequently dissolved. It is a major upgrade to 4.3 BSD, and it includes a new virtual memory system, changes in the kernel structure, and a long list of other feature enhancements. There are several widely used open source versions of BSD. FreeBSD is popular for internet-based servers and firewalls, and is used in a number of embedded systems. The latest version of the Macintosh operating system, Mac OS X, is based on FreeBSD 5.0 and the Mach 3.0 microkernel. NetBSD is available for many platforms, including large-scale server systems, desktop systems, and handheld devices, and is often used in embedded systems. OpenBSD is an open-source operating system that places special emphasis on security. Solaris is Oracle's SVR4-based Unix release, with the latest version being 11. Solaris provides all of the features of SVR4, plus a number of more advanced features, such as a fully preemptible multi-threaded kernel, full support for SMP, and an object-oriented interface to file systems.